life changes when in love, yeah. I surround my soul with the positivity. That's
You're welcome once more, viewers, to our class today. I hope you enjoy it. Let us go there. Previously, we've looked at conversion from one base to another. This time around, we are going to look at addition and subtraction of number bases. From our example here, we have solve A 101 in base 2 plus 111 and B 317 in base 8 minus 265 in base 8. Now, the process of addition and subtraction of number bases are done in similar ways as done when dealing with a base 10 calculation. The only difference is that we consider the place values in respect to the base. So if we are to solve this particular questions, we say 101 plus 111, we place them in order. This is plus in base 2. So we say 1 plus 1 is going to give us 2. But 2, remember, the rules governing base is that the number should not be equal or greater than the base. So since 2 is equal to base 2, we are not going to write 2 there. Instead, if you get any number that is equal to or greater than the base, you divide that number by the base and write down what remains. So if we say 1 plus 1, we have 2. So what we will do is to see 2 divided by the base, we are working with base 2, divided by 2, we are going to have 1, remainder 0. So you write that remainder 0 and carry that 1 to the next number. So we'll place it here. That is 1 here. With this 0 will give us 1 plus 1, another 2. Divided by 2, we have 1 remainder 0. We write that 0 here and carry the 1 to the next number. That is here, 1 plus 1, 2, plus another 1, 3. 3 is still greater than the base 2. So we divide 3 by 2 to have 1 remainder 1. You write the remainder 1 and carry the 1 to the next number. Since there is no other number here, we bring it down this way. And that is how to solve or to add numbers in other bases. So you look at the second example. Example B is subtraction of number base. Don't be moved that I just solved one question. We will see series of questions when we begin to look at wire question, but I just want to trace the topic from beginning to the end. So if we look at subtraction of number bases, 317 minus 265, as we have in our question, both are in base 8. Both are in base 8. Base 8. So what we are going to do is this. 7 minus 5 is 2. 1 minus 6 cannot go. We have to borrow just like we do in base 10. We'll move 1 from the next number. And if we borrow 1, you remember if it is in base 10 number, if we borrow 1, we'll call it 10. So this time around, we'll borrow 1 and call it 8, since it's in base 8. We'll borrow 1 and call it 8. Add it to this one, it becomes 9. 9 minus 6 will give us 3. And then 2 minus 2, because you have removed 1 from this 3, will now give you 0. So that is it. We have it in base 8. So what it means is therefore that 317 minus 2615 in base 8 is equals to 32 in base, equal to 32 in base 8. So that is how we add and subtract numbers in different bases. Of course, you can still do this thing we did this way by converting them individually to base 10, add or subtract, and then convert back to the base, to the original base. But you know that is a waste of time if we can actually do that directly. Okay, let's look at multiplication and division of number bases. This question says evaluate 321 times 25 in base 6. So both are in base 6. To do that, we say we multiply long multiplication as we do. 5 times 1 is 5. Remember, it must not be more than the base. 5 times 2 is 10. And 10 is greater than base 6. So you have to divide by the base. If you divide 10 by 6, you have only 1 6 in 10, remainder 4. So you write the remainder 4 and carry that 1 to the next. But before you do that, we have to say 5 times 3 is 15. 15 plus this one that we got here will give us 16. Now 16 is greater than base 6. So you divide 16 by 6 again. We are going to have 2 remainder 6. We have 2 6 in 16. That is 12. Remainder 4. We'll write that 4 again. And then carry the 2 to the next number after you multiply. But 5 has no other thing to multiply here. So we'll carry that 2 down to have 2, 4, 4, 5. Then we take the second digit again. 2 times 1 is 2. 2 times 2 is 4. It's still not up to 6. 2 times 3 is 6. And 6 is equal to the base. And we can write 6 here. So you divide 6 by 6 to have 1 remainder 0. So you write the remainder 0 and carry the 1 to the next. And there is no other next number. So you bring down the 1 here. Then you add. That's how we do long multiplication. Remember that. 5 plus whatever is here, you have 5. 4 plus 2 is 6, and 6 cannot be written here. So you divide by the base 6, you have 1 remainder 0. You write 0, carry the 1 and add to this 4. You have 5. 5 plus 4, 9. 9 is greater than the base. So you divide 9 by base 6. You have 1 remainder 3. You write the remainder, carry the 1, add to these 2. You have 3, and then you bring down this 1. So this is the answer. If you multiply 3, 2, 1, and 25 in base 6, you are going to get 13305 in base 6 as well. Then the second question is 1011 base 2 times 1101 base 2. We do the same. 1 times 1 is 1, 1 times 1 is 1, 1 times 0 is 0, 1 times 1 is 1. The next one is 0, of course, 0 multiply all of them will give you 0, 0, 0, 0. The next is 1, 1 multiply will give you 1, 0, 1, 1, 0, 1. Then 1 multiply again will give you 1, 1, 0, 1. Of course, the place position shifts by 1. So you bring down this 1, bring down this 1 plus 0 is 1. 1, 0, 0 plus 1 is 1. 1 plus 0 plus 1 plus 1 is 3. Because 3 is greater than base 2, you divide 3 by 2. You have 3 over 2 is 1, remainder 1. So we write the remainder and carry the 1 to the next number. 1 plus 1 is 2. You write 2. You can't write 2 there. So you divide by the base. You have 1, remainder 0. You write the remainder 0 and carry the 1 to this other one. It will be 2 as well. Divide by 2. You have 1, remainder 0. You write the remainder and carry the 1 to this one as well. It will be 2 also. 2 divided by 2 will give you 1, remainder 0. You write the 0, carry the 1 to the next number. Since there is no next number, you bring down the 1. So we have 10001111. So 1011 base 2 multiplied by 1101 base 2 will give us 10001111 in base 2, and that is the result of the product of these two number base. So that is how it goes. Remember, I said you can as well decide to convert this to base 10, convert this other one to base 10, multiply, and then take it back to base 2, especially when the numbers you are going to multiply or divide are not of the same base. You have to convert to base 10 before you do that. But in this case, you can choose to convert to base 10 before multiplying, but make sure you take it back to base 2 after you are done, or you multiply directly since they are of the same base. So let us now look at division. Let us now look at examples on division. Evaluate 2115 base 7 divided by 1212 base 7. We first of all convert 2115 base 7 to base 10. You remember that 0, 1, 2, 3. That's the place value we give to it. So we take it 2 times 7 raised to power 3 plus 1 times 7, 1 times the base 7 raised to power 2 plus 1 times the base 7 raised to power 1, then plus 5 times the base 7 raised to power 0. So if we simplify further, we have 2 times 7 raised to power 3 will give us 343 plus 1 times 7 raised to power 2 will give us 49 plus 1 times 7 raised to power 1 is 7 plus 5 times 7 raised to power 0 is 1. Then we'll go again. 2 times 343 will give us 686 plus 1 times 49 will give us 49 plus 1 times 7 will give us 7 plus 5 times 1 will give us 5. And if you sum these, you will get 747 in base 7. In base 10, sorry. 747 in base 10. We've converted 2115 base 7 to base 10. Then we do the same for the second number. 12 base 7 to base 10. We assign it 0, 1. So we say 1 times 7 raised to the power of 1 plus the second digit 2 times 7 raised to the power of 0. If we simplify further, we have that 1 times 7 raised to the power of 1 is 7 plus 2 times 7 raised to the power of 0 is 1. That will give us 7 plus 2, and that will give us 9 in base 10. So that will therefore mean that that question is now turned to 747 divided by 9 in base 10. And that will be, using our long division, we have 747 here and then 9 here. 9 divided 7 cannot go. 9 divided 74 will give us 8. 8 times 9 will give us 72. You subtract. This is a primary school long division. 7 minus 7 is 0. 4 minus 2 is 2. You bring down the next digit, so now we'll have 27. 9 divided 27 will give us 3. 3 times 9 will give us 27. And when we subtract, we have 0. So if 9 divides 747, that is 83. Remember, that 83 is base 10. So we have to take it back to base 7. And if we are taking 83 base 10 back to base 7, what we'll do is to divide 83 by 7, as we used to do. 83 divided by 7 will give us 11, and 6 will remain. 7 divided 11 will give us 1, and 4 will remain. Then 7 divided 1, since 1 is less than 7, you have a 0, remainder 1. So you read from bottom to top, so that our answer will be 146 base 7. So that is how you do division in number base. So we have seen that we've been able to multiply, divide, add, and subtract number bases. So this we'll call it the end of this topic, but we are going to solve series of questions in this topic because you are going to see other cases of number bases where you are asked to find some letters will be used to represent numbers, and you'll be asked to find those letters, and so many ways these questions can be twisted. We'll look at that. We'll pick WAEC and JAM questions as well and solve, so that we'll see how exam questions come under this topic. See you next time. Thanks for watching. See you in the next class. Don't forget to like, share, and comment. Probably if you have a question, do that in the comment section, and subscribe if you've not subscribed. No, go and subscribe if you've not done that, so that you get all our package when it comes.